Good morning, everyone. I, Ramya Sakpal, on behalf of Shayan Ankar Hachi Engineering College, Mumbai, welcomes you all to Hybrid Webinar Series 2.0, Innovative and Emerging Technologies in Field of Research. This series is hosted by SAKEC Research Cell. Let's begin this series of webinar by seeking divine blessings from Ma Saraswati. It's my pleasure to introduce the speaker for this session, Ms. Anna Marie George. She is an assistant professor in Department of Electronics and Communication Engineering at School of Engineering at Dayanand Sagar University, Bangalore. She has obtained her Master's in Technology in Digital Electronics and Advanced Communication and Bachelor's in Engineering in Electronic Communication from Manipal Institute of Technology. She is pursuing her PhD from Reva University, Bangalore. Ma'am has 7 years of teaching experience and specializes in FPGA-based system designs, digital signal processing, and intelligent controllers. Ma'am has done research on IoT involving as a megatrend in semiconductor industry and has published 11 research papers in international and national journals. Her area of interest include embedded system, signal processing, artificial intelligence, IoT, and she is member of technical societies like IEEE, ISTE, and ISSE. We would like to honor our guest with a sapling as a token of gratitude from SAKEC Research Cell. Ma'am, please accept.
Thank you. Thank you.
I'm very sure this 2-hour session will be the best technical session for all of us. Before handing over the session to our speaker, I have a few announcements for my audience. All participants, if you have any query in between, put them down in the chat box. Frequently asked questions will be taken at the end of this session. At the end, a feedback link will be provided in the chat box. Participants will receive e-certificate based on the information provided in the feedback form. Hence, please mention your name and email ID correctly in the feedback form. You must also upload a selfie in the feedback form. Now, I request our honorable speaker, Ms. Anna George, to please take over and start this session. Thank you, ma'am.
Thank you, Ramya. First of all, I would like to thank the organizers, Shah and Anchor Kachi Engineering College, for giving me this opportunity to share my knowledge on machine learning and signal processing. I also thank Vaishali Madam and my HOD, Dr. Vaibhav Sir, for supporting me in these activities. So with this, so very good morning. Myself, Anna Marie George. So I'll be giving a presentation on application of machine learning in signal processing. So as you all know, machine learning is one of the hottest career choices today. Data science and artificial intelligence creates about 2.3 million jobs, and it is one of the fastest growing technology employment areas today. And signal processing, as you all know, it is an engineering discipline that focuses on synthesizing, analyzing, and modifying signals. Or you can say it mainly focuses on modeling and analysis of data representation of physical events lying at heart of today's digital world. And when you couple both ML and signal processing, it brings a lot of opportunities, as well as it helps to make powerful predictions. So these are the agenda of today's presentation: a brief introduction to signal processing, machine learning and artificial intelligence, some of the machine learning algorithms, how to acquire real-time data with concepts of IoT, deep neural networks, some of the artificial edge devices, Python and MATLAB for AI, and few examples, some signal processing examples using MATLAB. So signal processing, when you talk, a signal is nothing but anything which varies with time. So most common examples for a signal would be an image signal or an audio signal, um, or a temperature signal, signals from any of the sensors. So those are all examples for signal. And another important entity in signal processing is a system. A system is something which is capable to manipulate the signal or extract certain information from the signal. So these two are important entities in signal processing. You have a signal as well as a system which is capable of manipulating and extracting the information. So in signal processing, mainly we try to represent these signals. We analyze its frequency content. So be it audio or image signals. Also, we have seen how to design and implement different kinds of filters, say IIR or FIR filters. So when we talk about signal processing in our daily lives, so there are plenty of examples where we can see signal processing in our daily lives. So if you see any smart connected devices, so it is enabled by signal processing. So even a telephone, whether it is a smartphone or not, it relies on speech processing techniques to make voice communication between two people possible. So from A to D conversion to speech enhancement to speech encoding on the recording side. So all these involves a lot of signal processing. And in modern days, you can find digital assistants such as Siri, Google Now, Cortana, so which are able to recognize a user's voice. So that is again signal processing. And when we talk about images, again vehicle detection or object detection. So again, it involves a lot of signal processing. So again, when talking about big data, when you're trying to predict the stock market or anything, so again there is signal processing which is involved. So if you see the communication and networks, so again when you're trying to use GPS to find your way, so that is again signal processing behind the scenes, which is transforming and analyzing the signals to help you communicate and learn from the technology. So these are all the different applications where signal processing is being used, and signal processing can be merged with machine learning to make powerful predictions. So not only to make powerful predictions, but also to make the process simpler. So next, coming to what is artificial intelligence. So the next engineering wave is all about artificial intelligence, machine learning, and deep learning. So automating tasks through machine learning models results in systems that can often make decisions and predictions more accurately than humans can do. So artificial intelligence is a very broad domain, or it's a technique where a machine is capable of mimicking human behavior. An example of an artificial intelligence or artificially intelligent machine could be an artificially intelligent robot. And when you talk about machine learning, it is a subset of artificial intelligence, say which makes use of certain statistical methods to enable the machines to improve with experience. So mainly when we talk about machine learning, you would be having a data set, and from the data set you would be extracting certain features, and based on that you would be making the predictions. And deep learning, which is another subset of ML, makes use of multi-layered neural network. So the difference between an artificial neural network and a deep learning is that in case of your deep learning network, there is no need to extract the features. So whereas in case of your artificial neural network, so if it is an image signal, from the image, the features has to be extracted and then given to an artificial neural network. Whereas in case of a deep learning network, directly the image can be given, from which the features are automatically extracted, and you would be able to perform the classification. So that is the major difference between the three domains: artificial intelligence, machine learning, and uh, deep learning. So now the question comes, when can we apply machine learning, or when can we apply artificial intelligence? So one area when you can apply machine learning is when you have a complex task or a problem involving a large amount of data and a lot of variables, and there is no existing equation or formula to solve them. You can go with machine learning. Also, when you have certain handwritten rules and equations which are too complex, or when the rules of a task are constantly changing, or the nature of the data keeps changing and the program needs to um, adapt, say as in the case of automated trading or energy demanded forecasting or predicting the shopping trends. So in all these areas, machine learning can be applied. So I'm sure you must be familiar with these people. So can someone put their names on the chat window? The name of the first person whom you see here, or can someone unmute and tell who are these people? The first person. So can you identify these people? Yeah, I think so. Yeah, the first one is, who is the first person? Yeah, it's right. First one is Jeff Bezos. He's the CEO of the Amazon. Yeah, who is the second one? Yeah, Tim Cook. Yeah, Tim Cook is the second person. And the third one is Sundar Pichai of Google. And the last one is Mark Zuckerberg from Facebook. So these are all the people who are involved, the companies which are involved with a lot of machine learning and artificial intelligence. So now coming to the question why this artificial intelligence is gaining its importance. So the first reason, so when you talk about machine learning, you would have probably used these learning algorithms even without knowing that you are using artificial intelligence or machine learning. Say, for example, when you are using the web search engine, such as Google or Bing, to search on the internet, a learning algorithm is implemented to rank web pages, or every time you use Facebook or Apple's photo typing application, it recognizes your face or your friend's face. So that's also again ML. And every time you read your emails, and your spam filter saves you from having to wait through tons of spam mail, So that's also again learning algorithm. So many a time without even knowing that we are using machine learning or machine learning or artificial intelligence is what we are using artificial intelligence and machine learning in our daily lives. And one of the reasons for the growth of artificial intelligence is the large data sets. The Silicon Valley companies, which are collecting web-click data and trying to use machine learning algorithms to mine this data, to understand the users better and to serve the users better. So mainly when we talk about IoT and IoT sensors, the amount of data which is generated is in large volumes. And that is one of the reasons why AI is gaining its importance. So the second reason is, so the ML is being used where we cannot program by hand. Say for the example would be autonomous helicopters or handwriting recognition or natural language processing. So these are all some examples where writing a program by hand is difficult and AI has gained its importance. And the third category where AI ML applies would be in creating self-customizing programs. So when you go to Netflix or Amazon or iTunes Genius, so it recommends movies or products or music to you. So that's again a machine learning algorithm. And there is no way you can write a million different programs for millions of users. So that is another reason why AI is gaining its importance. So mainly to create self-customizing programs, you need ML. So it would be very difficult to write millions of different programs for millions of users. So instead, if you see your Amazon or Netflix, it recommends certain music or certain movies or certain products based on your previous purchase or based on your previous choice. So these are some of the reasons why AI is gaining its importance. So next coming to, is artificial intelligence and robotics entirely two different fields, or are they related, or are robots an example for AI? Robotics is a branch that deals with physical robots. So mainly you can program these machines to perform a specific task. And you can consider these robots or robotics as an example for a narrow AI, which is the first stage of AI. So those machines are dedicated to perform a specific task. Say a robot which is designed to clean the house, or so it is designed to perform a specific task. So that is called as a narrow AI. And the second stage of AI is general AI. So we can say we are in this particular stage of AI, that is the general AI, where so it is capable of making some intelligent predictions. So based on the previous data, what is available. So that is called as general AI, or those are machines which are capable of mimicking the human behavior. So an artificially intelligent robot can be considered to be an example for a general AI. So in addition to simply cleaning the floor, if the robot is also able to find an optimum path, a path finding robot, or a robot which is able to detect certain obstacles, and that would be considered to be an artificially intelligent robot, or an example for general AI. And the third stage of AI is super AI, so which is right now can be found only in comic books and in movies. So that is the super AI, where the machines are capable of doing more than that of human beings. So that is called as the super AI, which is the future of AI. So these are the three stages of AI. You have narrow AI, which is dedicated to perform specific task, general AI, which is capable of mimicking the human behavior, and super AI, which can perform more than that of human beings. So next, coming to different types of AI. So the first one is called as the reactive machines. So these are machines which do not have any memory elements, but they are capable of reacting to some inputs with some output. So an example for such machines would be the Google's AlphaGo and the IBM's chess playing supercomputer, that is Deep Blue. And so if you take example of Deep Blue, it can identify the chess pieces and knows how each of them moves. So while the machine can choose the most optimal moves from several possibilities, it can't predict the opponent's moves. So that is called as reactive machines. So these reactive machines, they don't rely on the internal concepts of the world. Instead, it perceives the world directly and acts on what it sees. So these are considered to be machines without any memory. The second type of AI is called as limited memory AI. And there are three different examples in this particular category. There is reinforcement learning, long short-term memory, evolutionary generative adversarial networks. So the best example for AI with limited memory would be a self-driving car, which makes use of sensors to identify steep road traffic signals and civilians who are crossing the street. And the vehicles can use this information to make better driving decisions, and they can avoid accidents. So these kinds of limited memory machines, they make use of the recent past and try to make the future decisions. So the next kind of AI is called as the theory of mind. So an example to some extent which can be given for this kind of an AI would be the voice assistants, like the Google Maps. So in Google Maps, so when you're traveling, you would give certain instructions. So take me to this particular location. But say if you yell angrily at the Google Map to take you to another direction, it will neither show concern for your distress or offer any emotional support. So instead, the map application will return, and the traffic report and the estimated time of arrival will be shown. So that is called as the theory of mind machines. So the example for this would be the voice assistants, the Google Maps and the voice assistants like Siri and Alexa. And the last type of AI is called as self-awareness. So these are machines which have human level consciousness. They have the ability to think, desire, and understand feelings. So such intelligent machines with emotions and feelings are not, they do not exist as of now. It is only in movies and comic books that you can find such AIs. So coming to some examples of artificial intelligence in our day-to-day lives. And most of these examples are directly related with the signal processing. So when we tell signal processing, anything which involves image or an audio, there is processing which is involved with it. So the first example would be the face detection and recognition technology, which is used in the Snapchat and the face ID unlock on iPhones. Another example would be the text editors, which use a natural language processing algorithm to identify incorrect grammar usage, and also to see if there is any plagiarism. So Grammarly, there is a software which is available along with the Word documents, which can be used to correct the sentences. So that is an example of AI. Social media, so social media platforms such as Facebook, Twitter, Instagram, so all of them, they heavily rely on artificial intelligence. The smart filter, which is used to identify and remove the spam messages, or the smart replies. So whether it is Yahoo or Google, so as soon as you try to make a reply for a mail, you can see there are some text messages automatically appearing for the mail you intend to reply. Say thank you, or thanks, I received it. So you must have seen. So those are again examples for AI. So another example is the chatbots, which are used by many businesses to assist potential customers with their queries. So many of the hotel booking sites or trip travel management use these kinds of chatbots. So then you have the recommendation systems, the media streaming platforms such as Netflix, YouTube, or the Amazon, so which gives you recommendations of products or music. So that is another example for AI. So then you have the search algorithm. So that is when you search for something on Google. So there is a way those pages appear. So each page is being ranked based on AI. So then you have the digital or the voice assistants, the Alexa. So the Alexa's voice services, or the Google Assistant, or Siri. So these are all very good examples of how signal processing is used with machine learning. So how your phone is able to recognize a user's voice, and based on that, it is able to fetch the information you want. So then other examples are the smart home devices. There are smart refrigerators, which create a shopping list based on what's absent and what's present. So you have e-commerce, smart keyboard apps, smart thermostats. So these are all different examples for AI. So particularly because of the IoT sensors which are being deployed, AI becomes very important or very essential with these sensors. So image classification is another major area where AI is being applied. So particularly the deep neural networks is being applied in case of image classification. So if it is in case of a neural network, so if I give an image of a cat or a dog, the features of the cat or dog has to be extracted and then given to an artificial neural network. So whereas when it is a deep neural network, so there are convolutional neural network algorithms, or the LSTMs, so which will help you to extract the features and then make the classification. So the image classification has become very easy because of the deep neural networks. So though the deep neural networks involves a lot of hidden layers and this complex, but from the user side, it has simplified the task. There is no need to extract the features and give it to a model. So next, coming to the steps involved in machine learning. So in general, any machine learning model you take, so these are the 7 steps which are involved. So the first step is to gather the data. So gathering of data can be done either through some experimentation, or there are certain uh, repositories where data for important machine learning applications can be found. So one of the common repository would be Kaggle, 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 and UCI machine learning repository. So these are the repositories from which data for a given application can be extracted. So data can be obtained also from experimentation. You can perform certain experimentation and then so certain experiments can be done and data can be generated, or from these websites, Kaggle or UCI machine learning repository, the data can be generated. The second step is preparing the data. So the data what is obtained cannot be directly applied for a given model. Certain standardization techniques, certain normalization techniques has to be applied prior to giving to a model. So also in this stage, you can divide the data for training, testing, and validation. And then the third step is choosing a model. So there are different machine learning algorithms available. And to select which algorithm is right for your given application, so that also depends on different parameters, such as size of your data set, what is the interpretability. There are different parameters based on which you need to choose the model. And the fourth step is training. So training the model using the given data set, then evaluating or testing. So evaluation, evaluation or validating your model. So to see how well the model is performing. And then you have the hyperparameter tuning. So where you are trying to optimize the learning parameters. So any algorithm would have certain learning parameters also, so which can be optimized using this hyperparameter tuning. And finally, the prediction phase. So these are the steps involved in any of the machine learning algorithm. So next, coming to the training, testing, and validation phases. So training phase. So in general, data is split as training data set and testing data set. So usually 80% of the data set is used for the training phase, and 20% of the data set is used for testing. So once you train the algorithm on the training data set, the test data set can be applied and you can check whether it is working fine or not. So more the number of data set you have, better would be your model. And you can also have a validation phase. So in case of the difference between testing and validation is, so in case of validation, it is a part of your training data set itself, which is not used for training the algorithm, but you are using it for validating the model or seeing how the model performs. Whereas in case of testing, it is a new data set for which you're trying to predict the output. So k-fold cross validation. So this is one of the most commonly used validation algorithm used by many of the platforms. So it is called as k-fold cross validation, and one of the advantage of this k-fold cross validation is it avoids overfitting. So in case of k-fold cross validation, so if the entire data set, so it is divided into k equal parts. So if k is equal to 5, it is divided into 5 equal parts, and one of the part is set aside for testing. On the remaining 4 parts, your model would be trained during the first iteration. So during the second iteration, the second part would be kept aside for testing, and you would be training the model on the remaining 4 data sets. So this process is continued till k is equal to 5. So if it is a 5-fold cross validation technique. So this is one of the most commonly used validation technique in most of the platforms. So coming to different types of machine learning algorithms. So machine learning algorithms can be broadly classified as supervised and unsupervised learning algorithms. So in case of supervised learning algorithms, you have a labeled data. You have a labeled input-output data. So it's like learning with a teacher. So you know what you're sure about the output for a given input combination. So under supervised, again, you have classification and regression algorithms. So in case of classification algorithms, you have the support vector machine discriminant analysis, need-based algorithm, nearest neighbor. And in case of regression, you have linear regression, support vector regression, ensemble methods, decision trees, neural networks. So those are the 2 categories under supervised learning. And in unsupervised learning, it is an unlabeled data what you have. And so you are not sure about the output. So it's like a self-learning algorithm. So from that raw data, you are able to form clusters or associate certain patterns. So that is called as unsupervised learning. So under unsupervised, again, there are 2 categories. You have clustering as well as association. And some of the commonly used algorithms under clustering would be k-means, hierarchical, Gaussian mixture, neural networks, hidden Markov model. So coming to supervised learning. So in supervised learning, the algorithm is given with a right answer. And under that, there are 2 categories. You have the classification and the regression model. So in case of regression, you are trying to make a prediction, or you are trying to obtain a best fit curve for the given data points. So an example for the regression would be trying to predict the price based on the square feet. So you're trying to make a housing price prediction. So the regression model first tries to obtain a best fit curve for these data points, and then from the set of data points, you can make predictions for the other samples. Whereas in case of classification, you have a set of data points, say belonging to 2 different classes. So now when a new data point is given, you will be able to make a prediction as to whether the given data point belongs to which particular class. So that is called as supervised learning. So this is an example for a classification algorithm. So you can see here there are there are 2 different dots. You have red dots as well as blue dots. So red indicates a set of people who do not buy computers, and blue indicates the set of people who are going to buy the computers. So how is this classification done? So the classification would be done based on a learning algorithm. So if this is the classifier, so if the first figure is the classifier which is obtained, so you can see that some of the red points are wrongly classified, as well as some of the blue points are also wrongly classifier. So this would be another possibility of a classifier. So you can see it is still better than the first classifier. Or you can also have a non-linearly separable classifier. So all these, so first two, you can see they are examples for linearly separable or linearly separated classes. So you can also have non-linearly separated classes. So that is how classification works. So then you can also evaluate the classifier, that is you can use a test set with known outputs to validate the results. So once the classification is performed, so you can use certain data sets whose output is already known to validate the results. So regression. So the difference between regression and classification. So the major difference is in case of regression, your output is a continuous value. So the predictions what you make will be a continuous value. Whereas in case of classification, it would be a class, say class A or class B. So a new data point, when you're trying to classify it, it would be either the new point would either belong to class A or class B. Whereas in case of regression, your output is going to take continuous values. So in regression, mainly you're trying to obtain a best fit curve for the given set of data points. And then when you make a prediction, it would be your output would be a continuous value. So next, why is regression analysis important? So mainly when you want to study the relationship between the independent and the dependent variable, regression is very useful. So you can use it to find the trends in data to predict real or continuous values. So you can determine which are the most important factors. So if you have a set of factors which are affecting an output, so by performing regression analysis, you can understand which are the factors most affecting your output, as well as which are the factors least affecting your output. And these are the different regression. You have linear regression, polynomial regression, support vector regression, random forest, ridge, lasso, logistic regression, etc. So is there any doubts so far? So do you have any doubts? Do you have any questions? So next, coming to unsupervised learning. So in case of unsupervised learning, the data what you have is a raw data, or you do not. It's not a labeled. It's an unlabeled data. So it's something like this. It's a set of. It is a collection of different shapes. So now using an unsupervised learning algorithm, it is going to form clusters, or it is going to group similar patterns. So that is called as unsupervised learning, forming patterns from the given raw data or forming clusters from the given data based on, so usually similarity is taken as a metric, distance, similarity, or the distance between the features would be taken as a metric to form the clusters. These are some of the examples where unsupervised learning is used. So to organize computing clusters, social network analysis, so in market segmentation, as well as in astronomical data analysis. So if this is a data, a raw data, so this is how clusters will be formed. So usually a similarity would be taken as a metric. So based on how much the data points or the features are similar to each other, they are grouped together and the clusters are being formed. So now I have a question. So for the first question is, suppose you are working on weather prediction and your weather station makes one of the three predictions for each day's weather. So it is going to predict whether it is sunny, cloudy, or rainy. Would you use a learning algorithm? You would like to use a learning algorithm to predict tomorrow's weather. So would you treat this as a classification or a regression problem? So can you put the answers on the chat window? So you are trying to make a weather prediction. So where you're trying to predict whether tomorrow's weather would be sunny, cloudy, or rainy. And you would be using certain learning algorithm to make this predictions. So is this a classification or a regression problem? So this is the question. So can you put your answers on the chat window? Okay, there is one answer as regression. Any other answer? So can you tell why do you think it is a regression problem? Can you just tell?
Vivek, can you mic?
Yes, sir. Just ma'am, basically, I feel weather is predicted, based on whatever metrics the instruments have calculated, and regression algorithms generally take a bunch of, input features, process it, and then based on that, give you an output prediction. So maybe using that, we can, proceed with our weather prediction.
Okay, okay. But in this case, you can see we are trying to make a prediction for the weather, and you are trying to predict whether the weather is going to be sunny, cloudy, and rainy. It is not you're going to say that tomorrow's temperature is going to be, say, 23 degrees Celsius or 25 degrees Celsius. So you're going only to make a prediction like whether tomorrow's weather is sunny, cloudy, or rainy. So you can see that your output is not a continuous value. So it is instead just a class. So we are
I
going to
understand. So
say
you're
whether it
classifying it
is.
into discrete chunks.
Yes, it is
Got it.
being classified into three different classes. So that is why this is considered to be an example for a classification problem. So if the same problem, if it is supposed to be a regression problem, then you have to predict tomorrow's temperature. Say what would be tomorrow's temperature, whether it is 23 degrees Celsius, a particular value. So you can see the next problem. Suppose you're working on stock market prediction and you would like to predict the price of a particular stock tomorrow measured in dollars. So you want to use the learning algorithm. So would you treat this as a classification or regression problem? So what about this question? So with this question, so is it clear the difference between classification and regression algorithm, regression problems?
Yes, ma'am.
Yeah.
It's
So
pretty
the second,
self-evident now.
yeah, the second one would be an example for a regression problem. So where you're trying to predict the stock, which is measured in dollars. Okay. So that is what is intended with these questions, to understand the difference between a classification and regression problem. So another type of learning other than the supervised and the unsupervised learning algorithm is the reinforcement learning. So it is a machine learning algorithm. So where based on certain trial and error, you are going to make the predictions. So best example would be how you learn to cycle. So that learning to control a system through trial and error. So that would be an example for reinforcement learning. So the person who is helping you when you are cycling, he will give you just some indication that whether you are cycling correctly or not. So he will not give you the exact output, but he will give you some indication whether you are moving in the right direction or not. So that is called as reinforcement learning. So you can also consider this reinforcement learning as learning with a critic. So a critic will never tell you the right answer, but he will give you some indications whether you are moving in the right direction or not. So that is called as reinforcement learning. So an example would be the cycling process or learning to cycle. Other examples would be most of your gaming applications, the computer games are designed based on this reinforcement learning. So other examples would be the robot navigation, helicopter pilot, VLSI placement, and intelligent tutoring systems. So next, coming to the performance metrics in ML. So it is not enough you train a machine learning model using certain algorithms. So once you train a machine learning model, you should be able to analyze the performance metrics of that particular model. So only once you analyze the performance metrics, you can make a comparison with the different models which are available. So in case of classification problem, confusion matrix. So there is something called as a confusion matrix, which can be used to analyze the performance of the machine learning algorithm. So this confusion matrix is nothing but it's a table which is indicating the predicted output and the actual output. So if it is a two-class problem, your predicted output can be yes, your predicted output can be no, as well as your actual output can be yes and the actual output can be no. So accordingly, you can have these classes. You can have true positive or true negative, false positive or false negative. So from the confusion matrix, you can tell whether the given model is performing well or not, or you can make a comparison with the other algorithms. So if you have trained a data set using different algorithms, so using this confusion matrix, you can compare your results as well as you can see how well your model is performing. So you can see if the true positive and the true negative rates in this particular confusion matrix, if it is having a very high value, then it indicates that your model is good. So false positive and false negative, those are the cases where you are not getting the actual output, or so the predicted output is yes, whereas the actual output is no. In case of false negative, you can see the predicted output is no, whereas the actual output is yes. So these are the two wrong cases, whereas these are the two correct cases. Okay. So from the confusion matrix, you can draw conclusions about your model. So also there are certain metrics which you can calculate from the classification model. So for the first one is the accuracy. So the accuracy is defined as true positive plus true negative divided by the total number of predictions. So that will give you the accuracy of the model. So if these are the values, so once you have trained your model, so be it Python or MATLAB, both Python as well as MATLAB gives you the option of getting this confusion matrix. So maybe after a little while we can see how you can see this confusion matrix. And once you obtain this confusion matrix, you can calculate the accuracy of the model. So accuracy is defined as true positive plus true negative divided by the total number of predictions. So from these values also you can tell, you can say that the values of true positive and true negative, they have a higher value than false positive and false negative, which also says that your model is good, or your model is good for making the predictions. The next other parameters would be recall or sensitivity, or the true positive rate, which is defined as the true positive rate divided by the true positive rate plus the false negative. The specificity or the true negative rate, which is defined as the true negative rate divided by the true negative rate plus the false positive rate. Precision, which is defined as the true positive rate divided by the true positive plus false positive. So these are all the different performance metrics, or the different metrics which can be calculated from the confusion matrix. So it is only the confusion matrix which you can get once you train an algorithm. You will be able to get the confusion matrix, and from the confusion matrix you can analyze, you can calculate these parameters. So another parameter is F1 score, so which uses both precision and recall together. So F1 score is defined as 2 times of precision into recall divided by precision plus recall. So one of the performance metrics in case of your classification problems is using the confusion matrix. So using the confusion matrix, you can calculate the accuracy of the model, the specificity, the precision, and recall. So these are all the parameters you can calculate from the confusion matrix. So another parameter which can be used for the performance metrics of a classification problem is called as the area under the receiver operating characteristics. So this is so your ROC, the receiver operating characteristics, it is a probability curve, and the area under the ROC curve, it is going to measure the separability between the two classes. So if you have an area under the curve something like this, and if the ROC is something like this, it means that there is a perfect separability between the two classes. So TP indicates the true positive rate and TN represents the true negative rate. So if you have an AUC, that is area under the curve, as equal to 1, it means that there is a perfect separability between the two classes. So true positive will indicate that if there is a classification problem, something like whether you would be buying a computer or not. So buying a computer would indicate the true positive rate, and true negative rate is not buying the computer. So having an AUC of equal to 1 indicates that there is a perfect separability between the two classes. So you can also have AUC as equal to 0.7, so which means that there is some overlap, or you can say that there is 70% chance that the model will be able to distinguish between the two classes. So if you have AUC as equal to 0.7. If you have AUC as equal to 0.5, so you can see both the classes, they have overlapped, or you can say that the model is not able to distinguish between the positive and the negative classes. And the last case would be when AUC is equal to 0. So you can see here the true negative and true positive classes, they have interchanged. So which means that the model is reciprocating the classes. So that means when the model is predicting a negative class as positive class and a positive class as negative class. So this is another performance metrics which can be used in the classification problem, the area under the ROC, the receiver operating characteristics. So which will indicate the separability between the two classes, how well your model is able to separate the two classes. So this curve is also obtained using MATLAB as well as with Python. So those are the performance metrics in case of your classification problem. Coming to the regression problem, your performance metrics would be in terms of the mean absolute error, the mean squared error, and the R squared value. So these are the performance metrics in regression problem. So the mean absolute error is defined as the difference between the actual and the predicted output. The absolute difference between the predicted and the actual output divided by the total number of data points. And the mean squared error. So this is one of the most commonly used performance metrics in regression problems. That is the mean squared error. So which is the square difference between the actual and the predicted values divided by the total number of data points. So that gives the mean squared error. And another performance metrics would be the R squared value, which indicates the correlation between the observed outcome values and the predicted values by the model. So the R squared value, higher the R squared value, better is your model. So in regression, you are trying to obtain a best fit curve for the given data points. And if the R squared value is high, say if it is very close to 1, it indicates that the model what you have obtained is a good model. So it indicates how well the actual and the predicted outputs are correlated. So another important thing is the bias and the variance. So these are the two parameters which will indicate whether the model you have is an overfitted or an underfitted model. So bias is nothing but it's the difference between the predicted and the actual output. So high bias means the model has failed to understand the relationship between the input and the output data. And low bias means the model has understood all the relationship between the input and the output. And variance is how your model performs with a different data set. So when you give a new data set, how the model behaves. So that is called as the variance. So low variance means the performance of the machine learning model does not vary much with the different data set, and high variance means the performance of the machine learning model varies considerably with a different data set. So a good machine learning model should have low bias as well as low variance. So you can see for this given data set, you can see how an overfitted curve looks, how an underfitted curve looks, and what would be a good fit for this particular problem. So you can see this. So you can see this yellow line who is considered to be a good fit for this particular data set. So this is the true function, and for this true function, you can see this becomes an overfitted model where you can see the model has learned all the relationship between the input and the output. But when you give a new input test data, the model may not perform very well. And this would be an underfitted model where you can see the model has not learned all the relationship between the input and the output, but its performance with the new data set would be comparatively better. So for a good machine learning model, it should have low variance as well as low bias. So we have defined overfitting. So overfitting is nothing but your model is learning all the complex relationship between the input and the output. But when a new data set is given, your model does not perform very well. So that is called as an overfitted model. And underfitting thing is, during the training phase, your model does not learn all the relationship between the input and the output. But when you give a new data set, it behaves comparatively better. So that is called as an underfitted model. So both overfitting and underfitting should be avoided. And these are some of the techniques which can be used to avoid overfitting and underfitting. So to reduce overfitting or underfitting, you can increase the training data. And other techniques would be to reduce overfitting. You can reduce the model complexity. So when you reduce the model complexity, the model learning, the different features between the input and the output will also reduce. So thereby reducing the overfitting. And L1 and L2 regularization. So those are other techniques for reducing overfitting. So L1 and L2 regularization is adding certain penalty terms so that your slope is reduced. So particularly in case of your regression problems, by reducing the slope, for reducing the slope, you add certain penalty terms. So that is called as L1 and L2 regularization. And in case of underfitting, you can increase the complexity of the model, increase the number of features, remove noise from data, and increase the number of training epochs. So these are some of the techniques which can be used for so I can see there are some few questions here. Why digital signal processing is needed? So digital signal processing, one of the reason is its ability to reproducibility. So in case of your analog signals, that reproducibility is not possible. So reproducing the same output is possible in the digital domain, and also the amount of even if noise gets added with a digital signal, the way your output gets affected is very less. So those are the two reasons why you need to go for digital signal processing than analog signal processing. So you must have seen in olden days, you have a analog meter. So but these days you have digital meter. So if you take an analog ammeter or analog meter, you can see the way you're going to read the meter reading varies from person to person. So one of you may take the reading as say 12.5, another one may take it as 12.6. So it depends upon how precise that analog instrument is. Whereas in case of digital equipments, you are reading that measurement and all of you would be reproducing the same output. So to obtain that digital signal, you have performed quantization. So where you have allotted specific levels to each of those analog values. So each of you would be getting the same result in case of your digital output. And another reason is the noise. So particularly in communication, the noise gets added along with the signal. So if noise gets added with an analog signal, then the output what you get is going to be entirely different. Whereas in case of your digital signal processing, so if a digital signal is corrupted by noise, or if noise gets added to a digital signal, the output is not much affected. So these are the two reasons why digital signal processing is needed. The next question is how machine learning is used in sensor signal processing. So any of your signal data. So in machine learning, by machine learning, you need to have a data set. So the data set what you have may be generated from a sensor data. It can be from an experiment, or you would be using some data which is readily available in the website. So the data what you use, so it would be the data would be from an ECG signal, or the data would be from a temperature and humidity sensor. So say based on the sensor data, you want to predict whether a person will have a heart attack or not based on the ECG signal, or based on the temperature and the humidity sensor data, you want to predict whether there will be a forest fire. So these are all sensor signal processing. So that means from the sensor data, your so your data is the signal process. Your data is a signal, and that signal can be either in the form of a sensor data, or it can be in the form of an image, or it can be an audio signal. So all these, any signal you take, it involves signal processing, and using machine learning, you're just trying to make certain predictions. Okay. So in what aspects or which results help machine learning in signal processing improve DSP applications? Okay, so you're trying to say how machine learning is improving the DSP applications. So if you take an image classification problem, so if you are using a signal processing technique, so say you want to classify the images of different shapes. Say you have circle, you have triangles, you have rectangles. So you want to classify these shapes using certain signal processing techniques. So you can use either some correlation techniques. So you can feed those images. So but when an important thing when you do only with signal processing is that you need to extract the features. You need to extract the features of those shapes. So directly that image cannot be given in case of your signal processing when you are trying to apply certain signal processing techniques. So important is you will have to extract the features, and then you will have to make the classification. So whereas in case of your machine learning, that is not the case. So if you are applying a deep neural network to perform the image classification, directly the image of those shapes can be given. So the model is going to learn. The model is going to learn. So there are different layers which will help you to, which is going to learn the shapes, and based on that it is going to perform the classification. So that is the advantage of machine learning, or using machine learning in signal processing techniques. So another question is, how does signal processing, deep learning, and machine learning related? So I think I have explained that your input data can be any of the signals. It can be a sensor signal, it can be image, audio signal. And by applying machine learning, you are going to make the process easier. So that is the major advantage of using signal processing along with machine learning. Another question is, how does high variance work? So high variance means when you are giving a new data set to a given model. So you have already trained your model when you're applying a new data set, your model is not giving you the correct output. So that is called as a high variance condition. So you get high variance whenever you're giving a new data set to a machine learning model. Your model is not giving you the correct output. Okay, so that is called as a high variance condition. So particularly in case of your overfitted models, you can see this high variance. So because your model has learned the input-output relationship very well, it is not able to respond correctly for a different or a new data set. So that is called as high variance condition. What are the disadvantages of digital signal processing? So as compared to your analog signal processing, your DSP, your digital signal processing has a lot of advantages than the disadvantages. Okay. So if you tell the disadvantages, it would be in terms of the precision. So if you take an analog device, it will give you a very precise output. So you would have such equipments which are capable of giving you such precise outputs. Whereas in case of a digital output, when you perform the quantization process, so you would have approximated your output to some particular value. So though you are able to reproduce the output would be an approximate output. So that would be one of the disadvantages of your digital signal processing. How would you separate signals that are neither clearly harmonic nor clearly percussive? So that question, can you elaborate a little more on that question? How would you separate signals that are neither clearly harmonic nor clearly percussive?
Ma'am, I guess what he is separating signals from like a music file. Like say you're talking about classical music and you have percussion instruments and other harmonic instruments, and if you want to separate those signals, so that is probably what he's meaning.
Okay, yeah. So if you want to separate different musical tones, you can train the system. So the input would be an audio signal. So you should have a data set. So you should be knowing what kind of signals you want to separate, and you can train a model, and based on that you would be able to separate the signals. So maybe I will show you a few examples with MATLAB. Okay. So this is a program. So this is a very simple program which is making use of deep neural network to classify an image. So here I am, the first step, I am reading the image of a mouse, and so that image would be displayed. And in this step, say net is equal to Google net. I'm using a pre-trained network, a Google net. So similarly, you have AlexNet, you have RESTnet. So there are certain pre-trained networks already available. So which has already trained a set of images. So that is used here, GoogleNet, and I'm just resizing the image, and finally using the classify function, I'm trying to make a prediction for the given image. Okay, so the classification is done based on the pre-trained network. So the name of the pre-trained network is called as GoogleNet, and I want to classify this image. So the image what I'm giving is of that of a mouse, and my model should be able to predict it as a mouse. So I'll just run this and show you. Yeah, so this is the image. This is the image which is given, and so the model has to predict that this is a mouse. So you can see here, predict one, it is a mouse. So you can see that it is able to classify. So instead of a mouse, I have another figure here. Say, let me use a coffee mug. I have an image of a coffee mug, and I want to see whether it is able to classify that image as a coffee mug or not. So this is the image. So you can see it is making a prediction as coffee mug. So when you're using these pre-trained networks, you can say maybe for a set of 1,000 images, your network is already trained. So if your image belongs to one of these categories, it is able to make the classification. So it is able to classify it as a coffee mug or as a mouse. Say suppose that image does not match any of the images which are trained in GoogleNet, then it is not going to give you a correct output. So in that case, you can go for what is called as a transfer learning. So transfer learning is you already have a pre-trained network, and when you just add some more data set, say you want to classify, say, iris flowers, so which is not pre-trained in this particular GoogleNet. So you can give a set of images of iris flower to a GoogleNet, and then you can try to obtain the classification. So the advantage is you are using a pre-trained network, or you're training on a pre-trained network. So that is one advantage of using these pre-trained networks. And that technique is called as transfer learning, where in order to make predictions for new data or for images which are not already present in your GoogleNet, you can train the model, you can train your pre-trained network in order to perform the classification. So this is one example how image classification is done using using deep neural networks. So you can see how simple it is. You can see the number of lines of code that is being written to perform an image classification. So if you had to perform this using a normal signal processing or image processing technique, it would take it wouldn't be just these 10 lines of code. So it is surely going to be more than that. So that is the advantage of using a deep neural network over a normal image processing technique. Okay, so this is one example. And another thing which I would like to show you is there are certain apps in MATLAB. You have the regression learner app as well as the classification learner app, where you can load a given data set. And once you load the data set, you can train the model using different algorithms. And also you can analyze the performance metrics. So I'll just show you an example with that. So maybe I will load this iris data set. So this is so I'll just show you that the data set iris data set. So it's stored in X. Yeah. So your iris data set. This is how it looks like. I'll just show you that. Using an iris data set, so based on its sepal length, the sepal width, petal length, petal width, you are going to make a prediction of the given iris flower belongs to which particular class. So whether it is belong to Centosa, whether it is belong to versicolor or virginica. So you can see the features, the sepal length, sepal width, the petal length, the petal width. The features are being extracted, and you have a data set which is telling based on these features whether it is belonging to the class Centosa, versicolor or virginica. So now you can see there is an app here. So you can see there is a classification learner app. So if I load this data set onto that, I can use different machine learning models, and I can develop a machine learning model, as well as I can also analyze the performance of the model. So from the new session, so I have this data set in the workspace. So let me browse it. Yeah, so iris data. So that is the data set I'm using, and the response is column 5. And the predictors, that means the input for my training model, they are the sepal length, the sepal width, petal length, and the petal width. So these are the inputs, and here you can see the type of validation that can be used, cross validation. And also I can set the number of folds. So we had discussed about the k-fold cross validation, so which you can set. So then you can start the session. So once you start the session, so you can train the model. So you can see here there are different algorithms which can be used. You can use the decision tree, the discriminant analysis, the logistic regression, naive-bayes classifier, support vector machine, Ansible classifier. So there are different classifiers which can be used, and you can click on the train. So once the model is trained, you can see the confusion matrix, as well as you can see what is the accuracy of this particular model. So in that way, you can also Yeah, you can also train it with other models and you can make a comparison. So you can see this model has an accuracy of only 33.3%. And you can also see what is the prediction speed, what is the training time. So different parameters can be seen here. Also, you can see the confusion matrix for this particular model. So you can see if along the diagonal, if you have a higher value, it indicates that your model is good. So whereas in this case, you can see it is vertically done. So from the accuracy also, it is very clear that it is not a very good model. So in that case, you can go with a different model, or you can add more data set and again train the model. So you can also obtain the ROC curves. Okay. So these ROC curves, they work whenever you have two different classes. So it will be able to show how much it is able to separate the two classes. So you can also say if in a particular problem you have more number of predictors, you can perform certain kind of feature selection. Say you can eliminate certain features and see how your model is performing. Before that, you can also try with principal component analysis, and you can see if there are any redundant features. So in this case, in this example, it is not very much essential because you can see there are just 4 predictors and 1 output. Whereas if there is a problem where you have some 10 predictors, to check if there is any redundant feature, you can first go with the principal component analysis. You can remove the redundant information using this feature selection technique. So from once you do PCA, you can understand which are the features most important for a given classification problem. And using only those features, you can train model. So this is one good feature which is available in MATLAB, which is used for training a classification problem. So similar to this, you also have a regression learner app, which can be used for regression problems. So another example which I can share is on human activity detection and classification. So in this program, you are able to classify the human activity, say whether a person is running, whether a person is sitting idle, whether he is walking upstairs, whether he is moving downstairs. So certain data is loaded. So if you want to obtain those data, your smartphones these days have those capabilities where you can record these data. You can have a record of these data. So whether a person is sleeping, whether a person is moving, whether he is running, whether he is moving upstairs, whether he is moving downstairs. So you can have a data of that, and then using certain machine learning techniques, you can classify. You can classify the data as you can classify the various activities of a person. So here you can see how the classification is performed and what is based on the acceleration data. And based on the acceleration data, you're trying to detect what that person was doing. So you can see in this interval, the person was remaining idle, and after that you can see he was walking upstairs, and then there was a transition phase, and then you can see he was walking downstairs, and again there is a transition phase, and then you can see in this particular duration he was running, and you can see the acceleration data also. So when the person was running, and again there is a transition phase, and you can see the person was walking upstairs. So again you can see what is the acceleration data, and finally again the person is in idle stage. So this is a machine learning algorithm which is making use of k-means algorithm. So here you can see FitCKNN. So KNN algorithm is made use of to train the machine learning algorithm, and finally to classify as whether a person is walking, running, idle, whether he is moving upstairs or moving downstairs. So in case of your KNN algorithm, you are detecting the K nearest neighbors and then trying to form the classification. So there are different algorithms which you can use. So in MATLAB you have a function FitCKNN or FitCSVM or FitC FitCKNN, FitCSVM or FitCEnsemble, so which can be used with your data. So X is the data, is the raw data what you have, and Y is the different classes to which you want to classify this particular given data set. So another example which I can show is on. Yeah, so this is on a unsupervised learning algorithm. So which is making use of k-means clustering. So which is making use of k-means clustering to form the different classes. So we can just see the data first. So you can see how different clusters are being formed. Okay. So if you see the data. So this is the data which is used. Yeah, so based on the gender, age and annual income, you are trying to see what is the spending pattern of different groups of people. So you're trying to do a sort of customer segmentation. So different people in different age groups based on the gender and as well as their annual income, what is their spending score. So accordingly, you can see here there are 5 classes. So this was the raw data which was given, and based on the 3 parameters, you were able to form these 5 clusters. So the algorithm which is used here is called as the k-means clustering. So you can see what is the spending score of different groups of people. And one of the challenge in case of your k-means algorithm is to determine the value of k, and to determine, so in this case you can see the k was obtained as k is equal to 5 using elbow technique. So finding out that value, optimum value of k, is also very important. That means number of clusters to which the given data has to be segmented. So that is also important. So one of the techniques which can be used to determine that value of K is called as the elbow technique. So you can see this curve is like that of your elbow, the arms of your elbow. So that elbow point will indicate the minimum value of K which can be used. So there are different algorithms which you can use. You can use, say, FitC SVM or FitC Ensemble, and you can train. So in general, if you see the steps involved in your machine learning process, so first step would be to read the data, and to obtain this data, you can either use the Kaggle website or the UCI machine learning repository. So if you type this social network underscore ads.csv, you will be able to obtain this data either from Kaggle or from machine learning, UCI machine learning repository. And the second step here is the standardization process, where you are pre-processing the data. You are subtracting it from the mean and dividing by its standard deviation, so that all the parameters, all the predictors in your data, they are in the same range. And then you can apply different classification algorithms. And here you can divide your data. So here you can see CV partition, the classification model, comma holdout, comma 0.2. So which means that 80% of your data is used for training and 20% is used for testing. And finally, you can see you are making predictions, and you can also see the confusion matrix which is obtained. Yeah, so you can see how for the testing data set, how the classification is being formed, as well as for the training data set, how the classification is being formed. And you can also visualize the results. You can also visualize the confusion matrix. So you can see here the confusion matrix which is formed. And using this confusion matrix, you can analyze, or you can evaluate the accuracy, the precision, the recall, the specificity of the model. So these three are the major steps which are involved. So the rest of the program is mainly for plotting purpose. So you want to see that scatter plot along with the classification diagram. So that is why the rest of the program is written. So you also have the option of detecting a real-time image, and the count can be obtained in ThinkSpeak. So how you can integrate real-time data, and you can store that data onto your cloud using ThinkSpeak platform. So that option is also available with MATLAB. So in this particular program, using the webcam, you would be detecting the faces, and that data is transferred to the ThinkSpeak platform. So you can see here, so I have already created a channel in the ThinkSpeak platform, and I'm using the right key of that particular channel to write that particular count onto my ThinkSpeak platform. So that is another option available with MATLAB. So once you have that data, so in this case, you're trying to see the occupancy. If you want to see the occupancy of a room, you would be using a real-time camera, and that camera would detect the number of people in a room, and that data is being transferred to the cloud, or you are storing the data in in the ThinkSpeak platform, which can be used for further analysis. So that is another option with MATLAB. So there are different algorithms which are available in machine learning for regression as well as for classification problems. There are both supervised as well as unsupervised learning algorithms, and both MATLAB and Python, they are very powerful tools which can be used in the area of machine learning. And so big data analytics. So data analytics is another reason why you have this huge amount of data. So you can see these are the 5 challenges in case of your data analytics: the volume, the velocity, variety, veracity, and value. The 5 V's, which are the challenges in your data analytics or big data. The huge volume of data which is generated, the velocity with which these data is generated, the variety of data, the veracity or the quality of the data, and the value of data. So these are some of the projects that I've carried out. Some of my students have taken up in AI and machine learning. Forest fire prediction and control, health monitoring system, Sudoku solver using backtrack algorithm, real-time human detection and counting, predicting English Premier League match using ML, detecting fake news, AI-based value private assistant, and movie recommendation system. So when you talk about the unsupervised learning, the basket analysis is a very important application. So in your supermarkets, you must have seen the way the items are being arranged. So that is again based on certain analysis which is done. So say there is some sort of an association which is done between the items. So if a person buys bread, he's also likely to buy jam and butter. So those items would be kept together. So that is another interesting application in case of your unsupervised learning, the basket analysis, how the different products are associated with each other. And there are different techniques for finding the associated patterns. You have the a priori technique or the frequent pattern growth technique, which can be used to find which are the patterns associated with each other, and accordingly you can arrange the products in a supermarket. So these are some of the references you can use. You also have the TensorFlow Playground, which is a very useful platform for working with artificial neural network. So you can work with a different number of input layers, hidden layers, and you can see how your output changes. So you give different kinds of activation functions, how your output is going to vary. You can see using this TensorFlow Playground. And you also have a teachable machine app. So if you don't have MATLAB, you can just check with this teachable machine with Google. So you can just click on this link. So there you can give certain images and you can see how the images are being classified. So it is making use of the deep neural networks. Yeah, so that's all from my end. Thank you very much.